Welcome back to the course Geotechnical Engineering. As we discussed in the previous lecture about the soil, definition of the soil in terms of agricultural point of view, geologist point of view, geotechnical and civil engineering point of view. And before discussing about the soil and the formation of the soil, as we discussed about rock and as well as types of rocks. So now in this particular session, we will see some details about the rock and types of rocks, and then other formations and soil profile also. So coming to the topic called introduction and index properties of soil. So here, this is the geotechnical engineering start with the soil formation, and in this topic, introduction and index properties of soil, we will cover this. We will cover the following topics like soil formation, clay mineralogy and soil structure, moisture content, weight of soil with the relationship, weight soil relationship, we can call it as a weight volume relationship, relative density, grain size analysis, and as well as CO analysis. Then we use CO analysis for determining the grain size purposes, and principles of hydrometer method, consistency limits, and various indexes we will discuss in this part. And the IS classification of soils also is one of the major topic in this introduction and as well as index properties of soil. So coming to the soil formation, where as we the soil is actually formed due to the weathering process. This weathering may be in mechanical weathering and as well as chemical weathering, and after that soil new deposit will form from the parent rock, and that new deposit either it may be a transported deposit or it may be a residual deposit. And after that, another topic in this, it is clay mineralogy and as well as soil structure. So once after forming the new deposit, we are supposed to identify the type of soil deposit. So there are 4 different structures. Those are like single grade structure, honeycomb structure, folliculated, and as well as dispersed structure. So then from this combination of these coarse aggregate, fine aggregate, variance of water content and air content, we will determine we will measure the moisture content, and then we will solve this by considering the soil in terms of in terms of weight and in terms of densities. We will do some exercise on the various relationships. That is also part of this particular module. So here we'll start with the basic definition of the soil. The word soil is derived from the Latin. Actually, it is the Latin word of the soil is solium, which according to Webster's dictionary means the upper layer of the earth. So that may be a dug earth hole. So here the soil is a word actually which is derived from the Latin word called solium, and as per the Webster's dictionary, the soil is they define that the soil is the upper layer of the earth. Okay, so the term soil in soil engineering, this is another definition. The term soil in soil engineering or in geotechnical engineering also we can write here. Geotechnical engineering is defined as an unconsolidated material composed of solid particles produced by the disintegration of rocks. So the definition they given for the soil as per the geotechnical point of view, the soil is an unconsolidated material. So it is an unconsolidated, not a consolidated one. So it is an unconsolidated material composed of solid particles produced by the disintegration of the rocks. So here disintegration of the rocks is nothing but like after the weathering. So due to the weathering, the rock will disintegrate and then the newly deposit will form. So due to that process, whatever the output deposit we are getting, that actually related to the soil. So then that the newly deposit which is formed due to the disintegration of the rocks, the newly deposit is actually composed of various solid particles. Not there is no any unique soil particles. Like it is composed of different soil, and coarse aggregate may be present, fine aggregates may be present. So it is a unconsolidated material. So the void space between the particles may contain. Void space is nothing but, suppose if you take this is some deposit which is formed due to weathering and disintegration of the rock, and here the space between this one, I'm just representing with a dotted line. The space between these particle to particle, whatever the space is there, that is we simply call it as a void space. So this the void space between the particle may be contain air, water, and as well as both. So the space may be occupied by air. This particular space may be occupied by air or water. Some cases both. So the void space between the particle may be contain air, water, and as well as both some cases. The solid particles may contain organic matter. So the solid particles which are present in this may contain the organic matter, and the particles be separated by such mechanical means as a agitation in water. So if you these particles may also this deposit may also contain the organic matter. So by mechanical method, by using mechanical type of any by generating some vibrations or by applying some certain loads, so then we can easily separate them from the deposit. So here the soil mechanics is the study of the engineering behavior of soil. So we used to study this particular subject, these particular various topics. This study actually reveals the engineering behavior of the soil when it is. So the various applications we'll see now, when it is used either as a construction material, as a foundation material. So we use the soil for construction material and as well as foundation material. So we will study the behavior of the soil before applying the soil into construction material and as well as the foundation material. So an understanding of the principles of mechanics is essential to study the soil mechanics. The basic what they're saying, that understanding of the principles of mechanics. Principles of mechanics is very basic to understand the soil mechanics. The knowledge and applications of the principles and principles of other basic sciences such as physics, chemistry would also be helpful in understanding the soil behavior in detail and as well as in depth. So once if you thoroughly, once if you are well in understanding the principles of mechanics and as well as science and other applications of science and chemistry, then we can easily understand this particular topic called geotechnical engineering, and then especially soil behavior when it undergoes some action of wedging actions like some mineral composition. We can easily understand if you are well in application of this chemistry and as well as physics application oriented. So the applications of the principles of soil mechanics. So as of now we seen that what are the basic concepts are required to understand the soil mechanics in depth. So now it is after knowing this geotechnical or soil behavior very well, then the application of the principles of soil mechanics to design and as well as construction of foundations. Mainly we use where design and construction of the foundation for various structures is known as the foundation engineering. So another one is geotechnical engineering, and may be considered to include both the soil mechanics and as well as foundation engineering. So maybe considered as both. The application of these soil applications are for the construction activities, foundation activities, and we combinedly call it as a soil mechanics and as well as foundation engineering. So then if you see the various fields of soil mechanics, as we seen in the last slide about the application of the soil mechanics, it covers actually the foundation, where the foundation is required, some depth of exploration of the soil is required. So then after getting the soil sample from the various depth, we need to test the soil sample whether it is whether that extracted sample from certain depth, whether it is cohesive soil, cohesionless soil, and other properties are also we must test before selecting the any type of the foundation. And another major application of the soil mechanics is underground and as well as earth retaining structures, where this earthquake theories we need to be understand. So for that the soil basics are very useful. And the another major application is pavement design. So as we know that for flexible pavements there are different layers like base coat, sub base coats, like that. In all those cases we used to apply this soil. So then it is very important to know behavior of the soil under certain loads. So then only we can easily understand the behavior of the soil when the same soil sample is under pavements. So then another major application is excavation activities, embankments, and as well as dams. So like while constructing the retaining structures, and while constructing the earthen dams, so we will use this we need to we will apply the soil mechanics, and we will use to apply various soil samples. And then it is very important to know that the behavior of the soil when it is placed with some amount of sloping, and when it is undergone some load, like load during the dam constructions. So the soil formations, soil definitions we seen, and the applications also we seen. First of all, we should know that what is the major, how the soil get formed. So as soil is formed due to the disintegration of rocks, and the disintegration of rock will occur due to the weathering action. So then, so weathering, disintegration and as well as weathering will occur only the deposit of the rock is whenever it is continuously open to the atmospheric, the weathering will take place and the disintegration will take place. And then this weathering is actually in two types. One is mechanical weathering and the other one is the chemical weathering. So this mechanical weathering due to the changes in the temperature, wedging action of the ice, spreading the root plants, and as well as absorption. So in other way, the chemical weathering is due to hydration, carbonation, and as well as oxidation. So from any one of these process, some new soil deposit will form, and for the formation of the soil deposit, for the formation of new soil deposit, some transporting agent is responsible. That transporting agent might be water, or might be ice, it might be lake water, and marine, seawater, might be a seawater. So whenever, if the transporting agent, if see, this is the water, the type of soil which is formed due to this transporting agent is a alluvial soil. It is what? Alluvial soil. And from the this glacial, from the ice, marine type of soil formed due to the transporting agent of seawater. And then similarly from the lake water, lacustrine type of soil, and from air is a transporting agent. Air is what? Transporting agent and it will form the aeolian type of soil. And this is the transported deposit. And another one is the residual deposit. Here the residual deposit or residual soil, transported deposit or some transported soil is nothing but based on the distance from the parent rock. Suppose if you take, this is a parent rock, this is what? Parent rock, and due to the disintegration, this weathering is taken place. Any one of this weathering. Suppose if you take some certain from this parent rock, within the from this parent rock, within a shorter distance, some rock new deposit is formed, and say some another deposit formed compared to this, it is very far away from this parent rock. In this case, so for the formation of this the deposit number 2, I am just giving the numbers for clarity. So here this is the one which is formed newly, and this is the one which is formed after several days. So this is due to what? This is due to some transporting agent is responsible for the formation of this deposit and for the movement of this deposit from this place to this place or this place to this place, anyone. So based on that transporting agent, we have like water, ice, lake, and as well as seawater, air. We have these many transport deposits. Any one of them may be a reason for the formation of this river. So this is transported from initially it is placed very near to the parent rock, and actually due to these agents it is transported away from the parent rock. So then this is what? Residual soil deposit, and this is a transported deposit. So whenever the newly deposit which is very near to the parent rock is simply we call it as a residual deposit. Whenever if it is formed away from the parent rock, we will call it as a transported deposit. So now continuation to the soil formation. As I am discussing about the weathering of rocks, the soil is formed by the process of weathering of rocks. That is, this weathering is disintegration and decomposition of the rocks and minerals. So weathering will occur from the disintegration and decomposition of the rocks and minerals at or near the earth surface through the action of natural or mechanical and chemical agent. So the disintegration is taking place due to the natural, chemical, and as well as mechanical agents. So, and once after taking place of this disintegration, if the parent drug will get weathered, and that from that process, finally smaller particles will form. These smaller particles only we will call as a some deposit, soil deposit. It may be a residual deposit or it may be a transported deposit. The factors of weathering. The factors of weathering may be a atmospheric weathering. To take place of the weathering, the various factors influence are exactly the reason for causing the weathering is temperature and pressure, erosion and transportation by wind, water and glacial, chemical action such as crystal growth, oxidation, hydration, carbonation, leaching by the water, and especially rainwater with the time. So to take place of the weathering, these are the reasons in which temperature and pressure are comes under the or comes under the in which temperature and pressure comes under the mechanical, and as well as this oxidation, hydration, carbonation will comes under what chemical disintegration. And it is to be noted that 95% of the earth crust consists of igneous rocks. So we'll discuss about this igneous rock. So 95% of the earth crust consists of igneous rock, and only a remaining 5% consists of another two types of rocks is called sedimentary and as well as metamorphic rocks. So then what we are saying here, this weathering of rock will be occurred. So this weather due to this weathering of the rock, the smaller particles will form. So that this particular rock is actually a three types. This particular rock is actually what? How many? Three types. One is igneous, sedimentary, and as well as metamorphic. So there are three different type of rocks. From these, after weathering, smaller grains will be formed, and that we call as a soil. This is continuation to the soil formation. The rocks from which the soils are formed due to the process of weathering are called the parent material. So suppose if you take one rock, if you take one rock like this, so the soils are formed due to the process of weathering are called as parent material. So this is a parent rock. This is a parent rock, and from this, due to the action of edging action and oxidation, hydration, so this parent rock might get disintegrated and a newly deposit will form. Okay, now based on the origin of this rock, based on what? Based on the origin, and the rocks are classified as igneous rocks, sedimentary rocks, and as well as metamorphic rock. So these types of rocks, igneous rocks, are nothing but these type of rocks are formed due to the solidification of the magma. So the examples of the igneous rocks is basalt and as well as granite. And the sedimentary rock is these type of rocks are formed after the deposition of the weathering of other sources rock like sandstone, siltstone, shale, and as well as limestone are the examples. So 95% of the rocks are igneous only. 95% of the rock are igneous only. So suppose if you take some rock as igneous, after disintegration of that igneous rock, another new deposit will form. So that might be a sedimentary. And metamorphic. Metamorphic is these type of rocks are formed in the process of metamorphism due to the high temperature and as well as high pressure. So if due to the action of high temperature and high pressure, some new deposit will form from the sedimentary or maybe from the igneous. that newly formed sediment, newly formed deposit or newly formed rock, we will call it as a metamorphic. So that process of when it is when it is getting separated from the previously existing rock, maybe a igneous or maybe a sedimentary, that process is called as metamorphism. This metamorphism is occurs due to the very high temperature and as well as pressure. So then the final rock which we are getting due to this metamorphism phenomenon, that we call it as a metamorphic rock. So the mineral of the original rocks gets changed in this process, and in this metamorphism process, the minerals of the original rock, where original rock is nothing but igneous rock and as well as sedimentary rock, and these minerals will get changed and the new rock type is formed, that is we called as a metamorphic rock. And the examples of this new metamorphic rock are quartzite, sneet and gneiss and as well as marbles are the examples for the metamorphic rock. Okay, now, so if you go in detail into the weathering, and it is actually a process of the formation of the soil in which the rock gets disintegrated to form the soil particle. So finally, after weathering, what we will get, the rock will disintegrate and it actually form the various soil particles. So the weathering of rocks can take place as mechanical weathering. The weathering of rock takes as mechanical weathering, and the other one is chemical weathering. Chemical weathering. So in this process of the rock disintegrates into smaller fragments. In this process of mechanical weathering, the rock will disintegrate into smaller fragments, and the forces responsible for the mechanical weathering are temperature changes. Due to the sudden changes in the temperature, some disintegration of the existing rock will occur. That is due to the mechanical weathering, and that we call as a mechanical weathering. And another forces is wedging action of ice, spreading of the root of plants, and the other one is absorption. So it is actually, this absorption is due to the movement of air, water, glacier over the surface of the rock. So if any one of these four agents are responsible for the formation of the newly rock, and this we call it as a mechanical weathering. This is the type of rock which is formed due to the transportation, wedging action of ice and absorption, that we call it as the deposit which is formed due to the weathering of mechanical action. So when weathering will occur, so the flow of soil we can see here, the action of the force, temperature, gravity, wind, rain and as well as chemical weathering are continually forming rock particle that are eventually become a soil. So to become a soil, these actions, temperature, gravity, wind, rain and chemical weathering, and when these are continuously acting on the rock, then the rock will get disintegrate and the rock will get the smaller particle will be formed from the rock, and that smaller particles we will call it as it become as a soil. So these are the three type of soils when considering the modes of the formation. So the three type of soils are clay, silt and as well as sand and as well as gravel. So these are the various soil deposits. So these are actually formed due to the weathering process from the pre-existing rocks like metamorphic, sedimentary and as well as igneous. So then based on this mode of formations, we classified the soils are into three deposits, in which the first one is sand and gravel, silt and clay. So exact difference between the silt, gravel and as well as sand and clay we'll discuss in the coming slides. So now we'll see about temperature. So temperature is one of the mechanical agent which is responsible for the formation of the soil. The temperature actually changes. The temperature changes cause mechanical weathering in the rock. So when due to the sudden increases in the temperature or when sudden decrease in the temperature, these changes are actually causes the mechanical weathering in the rocks. It is due to development of thermal stress induced by the repeated expansion and as well as contraction of the mineral grains caused by changes in temperature. So the reason for the changes in the temperature is the thermal stress induced by the repeated expansion and as well as contraction of the mineral grain Okay, so these repeated expansion and contraction of the mineral weakens the rock properties and then break them into the species. So it actually it actually weak the composition of the rock properties, and finally smaller the rock will divide into various small fragments, and that we consider as a soil. So then another agent which is responsible for the formation of the soil through this mechanical weathering is wedging action of the ice. So you will see in detail about this wedging action. So the weathering of the rocks takes place due to the freeze through action of the water present inside the pore space. So if you take this is the rock sample, and this is the water, and in another case, if you see, this is the ice which is formed inside the rock fragment. Okay, now so when the water present when the present inside the rock gets frozen and its volume gets expanded due to the presence of water, the volume gets expanded and applies pressure to the surrounding of the rock. So due to the presence of this water within inside the rock, the volume of these particles and volume of this within the mass of the soil, mass of the rock will expand and surround will expand, and then it applies the pressure to the surrounding rock and causing to break the rock sample. Okay, now so the weathering of the rock take place due to the freeze throw and action of the water present inside the pore space of the rock. So due to the this wedging action of the ice, whenever if you consider this is a rock, and when there is a presence of when there is a presence of what when there is a presence of water, when this water is becomes ice, so this causes some swelling in the rock mass, and as well as it applies some extra pressure within the soil rock mass, and then finally it breaks into pieces. That pieces will form a soil. And the absorption, another weathering process, one is absorption. The rocks collides against each other. So in this absorption, the rocks collides against each other while it moves down to the action of the water or gravity, wind or glacier, and breaks into the smaller pieces. When they collide each other, it actually the rock particles will actually move down to this any one of this agent. So that agent is maybe a water, gravity, wind, or glacier, and then finally after fragmented, the new smaller particles will form, and the smaller pieces will consider as a soil. Then the spreading of roots. As the roots of the plant grows inside the pore space, like inside the pore space, this inside the ground surface, the roots of the plants grows inside the pore space of the rock. It widen the pore space and finally breaking the rocks. So suppose if you take if you consider some rock is there, so it might be go like this, it may be go like this. Finally the rock will broken into the pieces. That is also considered as a soil. So in all this process, no changes in the chemical composition. It is only due to the these the temperature changes, wedging action of ice, absorption and spreading are only the prime responsible for the mechanical weathering, not chemical weathering. So in this process, we not at all discussed anywhere the soil, the chemical composition of the fragmented small pieces will be changes like that. So this is only a mechanical. In this, we won't see any changes in the chemical composition of the minerals or anything of the soil. Okay, so in all this process, no changes in the chemical composition of the soil take place. So the examples is sand as well as gravel. So now we will see into the chemical weathering. The fragmented rock particles from the mechanical weathering process further gets disintegrated, and the chemical this is due to what? This is due to weathering process. The fragmented rock particles, as we said, the rock particles will form due to the various reasons like sedimentary and metamorphic. So from the mechanical weathering, this is due to what? Mechanical weathering, and further it disintegrate. So further after mechanical weathering, the deposit which is formed, So this may be formed due to, consider this is formed due to the mechanical weathering, and further this rock disintegrate and some new deposit formed. So in this case, this process is further gets disintegrated in the chemical weathering process. So this due to the chemical weathering process, some new deposit formed from the uh, deposit which is formed by the mechanical weathering. So when chemical decomposition or chemical weathering of the rock take place, original rock minerals are transformed into the new minerals by the chemical reaction. Now here some chemical reactions will change, and the mineral compositions also changes here. So in this chemical decomposition or chemical weathering of rocks take place. Original rock minerals are transformed into a new mineral by the chemical reaction. The soils are formed do not possess the properties of the parent rock. So the parent rock is nothing but the igneous rock. So it is already disintegrated and uh, weathered through mechanical process, and now from this deposit only another rock is formed, and it is due to what? It is due to the chemical weathering. Here, this soil, the newly one, this soil formed do not possess the properties of the parent rock. So parent rock we can consider this one for this. The parent rock is this one. Okay. So rate of chemical weathering depends upon. So the rate of chemical weathering depends upon surface area, temperature, presence of water, and the presence of chemical in the form of leachate. So these are the various parameters will influence the rate of the chemical weathering. So then chemical weathering, warm and as well as humid climate. The climate like warm and as well as humid produces high rate of the chemical weathering. In generally, the climate warm and as well as humid climate produce the high chemical weathering, high rate of chemical weathering. So this chemical weathering is hydration is one of the process of due to the chemical weathering. In this process, the rock minerals absorb water and forms hydrous compounds. So in this hydration process, but the rock minerals absorb water and forms hydrous compounds, which results in increase in the volume of the particular rock. And due to these increases in the volume, the rock gets fragmented into the pieces, and minerals such as silicate, oxide of iron, and aluminium, and as sulfate absorb the water molecules. So as like in the previous case, when due to wedging action of the ice case we seen, when the water is present within the rock mass, then the volume of the rock mass gets increased. It applies some pressure, then due to that pressure the rock gets fragmented, and the final some small pieces we will get, that we will consider as a soil. Here also you can see here rock minerals absorb some water, and due to the absorption of this water, the volume of the rock will get increases, and that increases, and finally it breaks into the small pieces. Okay, now so in this the minerals such as like silicate, oxide of iron, aluminium, and as well as sulfate are the prime responsible for taking place of the hydration process. So another one is carbonation. So the carbonation, carbon dioxide reacts with the water and carbonic acid will formed. Okay, so then it actually changes the mineral composition, and as well as mineral chemical composition due to the carbonation agent. And the another one is oxidation. Atmospheric oxygen reacts with the minerals in the rock to form a oxide. And hydrolysis, it is a reaction between the H plus and as well as OH minus ions and the water and elements of the iron in the rock minerals. So these are the various hydration, carbonation, oxidation, and hydrolysis are the prime responsible for the changing the chemical composition of the mineral, and these are due to the chemical weathering. These are the due to what? Chemical weathering. The chemical decomposition of the rocks results in the formation of the clay mineral. So as we seen in the three soil deposits, those are silt, clay, and as well as sand or gravel. And the chemical decomposition is prime responsible for the formation of the clay minerals and the clay soil. The clay soils are formed due to what? Chemical decomposition. Chemical decomposition. Transport and another if so after this chemical weathering, and as well as mechanical weathering, the new soil get formed. New soil deposit will get formed, and for changing the position of the soil deposit from one place to another place, here the transportation of this we call it as what? Transportation of the soil. So the agent responsible for the transportation of the soils are water. The first agent is very major one. It is responsible for the formation of the transported soil, and this is water, running water, particularly river especially we call it as, this is the main source for the transportation of the weathered rock particle. So from the origin, if you take this is a origin, from here due to this water, suppose for example if you take the water is flow like this, so these running water responsible for the for the fragmenting of the this rock into small pieces and the formation of the new soil. So depending upon the water flow intensity, when the flow is further reduces, like finally the clay, silt, and as well as sand will form. So all the type of soil carried and deposited by water are known as a alluvial deposit. The transport agent, which one? It is a water, and the soil deposit, in case if this due to this water some soil deposit is formed here, and say for example this soil deposit formed due to the transporting agent of water, and this we call it as a alluvial. This we call it as what? Alluvial deposit. So the deposit made in lake, in case if it is a river water. In case if it is the deposit made in case of lake, and we call it as a lacustrine deposit. We call it as what? Lacustrine deposit. Another transporting agent is wind. The soil transported and deposited by air is called as what? Aeolian deposit. So as like from the river water, alluvial soil, and from the air it is called as what? Aeolian deposit. Aeolian and deposit. Process is the example for this aeolian deposit. And glacial. So for the formation of this soil transported and as well as deposited by the glacial are known as the drift. So it is due to what? Ice. It is due to ice. So another agent is gravity. The soil transported and as well as deposited due to the action of the gravity are known as a colluvial soil. Talls is the example for this type of soil. So the soil which we formed due to the transporting agent of gravity, we will call it as a colluvial soil, and from the glacier it is we call it it is glacier type of soil is due to the ice, and as well as wind aeolian is from what? Wind. So these are the various transported agents. And the alluvial soil, if you see, it is present mostly in large part of the northern Indian states, alluvial soil. So for the formation of this alluvial soil is river water is responsible. So these type of soils are mostly present in northern Indian states, and these soils are characterized by the formation in a layer of sand, silt, and clay. So we can characterize this alluvial soil in the form of characterized the formation of this alluvial soil in sand, silt, and as well as clay. The color of this type of soils is varied from the light grey to ash. So the alluvial soil which is spread over the northern Indian states, and the color of this is light grey to ash. These type of soils are very fertile and as well as contain the potash and phosphoric acid and as well as lime. So the alluvial soil which actually very well contain the potash, phosphoric, and as well as phosphoric acid and as well as lime. So red and yellow colored soil. So these type of soils are generally present in central and as well as southern and northern part of the India. The red color of the soil is due to the diffusion of iron in crystalline and as well as metamorphic rock, and as well as looks yellow when it occurs in hydrated form. So this we can see this type in southern and as well as northeastern part of the India, and this is the color of yellow and as well as red of soil is due to the diffusion of the crystalline metamorphic rocks and the looks like yellow when it occurs in hydrated form. These type of soils is poor in nitrogen, phosphorus, and as well as human. Okay, so another one is block cotton soil. So this type of soil is generally present in central and as well as some portion of the southern India. This soil exhibits a volume change characteristics, like when you add some water into the block cotton soil, the volume will increases, and at the same time when especially in case of summer, it will shrink also. Okay, so when subjected to a change in the water content, so swell and as well as shrink. So subjected to the changes in the water content. So another one is arid soil. The most part of the Rajasthan is covered with this type of soil, and it mostly consisting of fine sand present in the loose state. And first soil is most part of the mountains and valley of Himalayas consists of this type of soil. Another one is laterite soils. This type of soils is mostly found in Karnataka, Kerala, Madhya Pradesh, Odisha, and as well as Assam. Laterite soil you will find in these states. And this type of the laterite type of soil is developed in areas with high temperature and rainfall. These type of soils are poor in organic matter, nitrogen, potassium, lime, and as well as potash content, and rich in iron oxide. Generally, these soils are red in color. Laterite is in red in color. Another one is marine soil. So the transporting agent is seawater. So this type of soil actually deposits present in the coastal regions. Generally, this type of soil possesses lower shear strength and high compressibility characteristics. So these shear strength and compressibility are actually a engineering properties of soil. So the marine soil actually possess what? Possess low shear strength and as well as high compressibility characteristics. Okay, now. So coming to the summary, as we discussed about this weathering, transportation, deposition, and as well as the upwell, the stages of the soil formation. You can say soil formation steps. Soil formation steps or stages. Okay. So once after soil is formed through any one of the mechanical or any one of these weathering and any one of the transporting agent, some profile will create. So that profile maybe consist of different rock types and soil types, as we discussed in many of the soil types. So here you can see, if you take this is the ground surface and the zone of leaching of the soluble salts, you can see this we can call it as a topsoil, and the zone of accumulating of the salts is we can call it as a subsoil, and the weathered parent, this is a bedrock. So after certain depth from the ground surface, the entire portion we call it as a bedrock. Okay, so the deposit of soil material resulting from one or more of the geological processes, as we discussed previously, like weathering processes and described in the earlier, it is subjected to further physical and chemical changes which are brought about by the climate and as well as other factors prevalent and subsequently. Generally, three distinct strata or origins. Strata is also we can call it as a origin or layer. So occur in natural soil profile. So this number may increase to 5 or more in soil which are very old or in which the weathering process have been usually instanced. So this is the naturally created soil profile. In this case, this is due to any one of the chemical and as well as the mechanical weathering action. And you can see here the bedrock is after certain depth. The bedrock is very hard. So it is very hard. So you can if you discuss in detail about this soil profile from the top to bottom of these origins. So each one is origin 1, 2, 3, 4 like this. So from top to bottom, these origins are disintegrated as a origin B origin, and as well as origin C. As you can see, origin A, B, and as well as C, C2. So here the top, the origin A is actually covers up to 30 to 50 meters, and then 60 to 100 meters, and this is or we can call it as a odd rock, and then very hard rock we can say. So as you can see, A actually describes light brown low leached one, and it is the color of this origin B soil, which is in dark brown clay, and the light brown silty clay is a C origin C1, and the light brown silty clay is origin what C2. So these are various characteristics of the each soil profile in case of origin A to C. And with this, I am closing today's lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.